All right. Starting a new chapter, new life.
Taking notes today.
Right now.
Clean out my water burns my throat.
Mrs. Schwartz, taking notes.
Well, guess that's been my mission in life, ruined days.
Matt Casey gave me a burning fire piece of gum, so now I feel like... Are you recording right now?
Yep, I am.
I told you.
Is this chapter easy?
Do you want to...
Half, if that was the question. Half of it is easy, half of it is very challenging.
Is it like more challenging than the... Is there going to be story problems?
That's what makes them challenging, yes. We end this chapter with story problems again.
You're like the whitest kid I know.
I know.
Okay.
That's why it'd be funny if I.
You saw radian mode. Listen now, let's focus. You saw radian mode on your calculator in the last chapter, and we were in degree mode. You didn't know anything about radian mode. Now you're going to learn about radians. It's another way to measure angles, and it's a much better way to measure angles. And what a radian angle measure is it's the number of radius lengths around the arc of a circle determined by the angle, if that made any sense.
Not at all.
Not at all.
It did to me.
Did not.
You're so
We use somebody's own.
You lie, lie, lie. So, I'm going to go with a very straightforward, intuitive approach first. So let's look at the concept of radian angle measure, so you actually know what my definition means. Okay.
Definitely take up for that machine photo. I can't help you there. Just making close.
Not too big. Okay, let's just say this circle has a radius of 4 inches.
I need to get something that draws like shapes for me. Mine are awful. To make those.
Protractor.
Yeah, but that's still a lot of work.
Yeah, that's a lot of work. I wanted another color here. Let's see.
Like something you just put down, it's like circle down.
Water bottle.
Put it back in back.
Oh,
No.
let me go with this.
That's lazy.
Okay, if I was to walk along the arc
Wait, what did you say?
Invented to become...
exactly 4 inches, pay attention.
Shh, you're distracted.
So just estimate. Oh, maybe that's a little far, right about to there. If this arc distance here was 4 inches, and then I was to draw the other side of my angle to that stopping point. So my radius was given as 4 inches, and I made an arc length of 4 inches, and then I made my angle have those endpoints. This angle measure in here would be exactly 1 radian. So because this arc length is equal to 1 radius, the angle measure is 1 radian. 1 r.
So is that an actual angle measure? Or is it
That's an angle measure now. 1 radian is an angle measure. And it's 1 because the arc length is exactly 1 radius length.
So that's a 1 that you're not
1.
connecting?
Nope, that's a 1.
Wait, so if the outside thing was 8 inches, would it be 2r?
It would be a half of a radius, so a half a radian. I'm going to do another one. Pay attention. Stick with the same circle, same 4-inch radius.
What's on the inside of that?
1r means 1 radius. I mean 1 radian. The angle measure here is 1 radian. I'll say theta equals 1 radian. So this time, if I go, instead of going a full radius, let's say I go 2 inches. estimating 2 inches, and I make my angle to the end point of that arc, what do you think that angle measure in there would be in terms of radians?
A half a radian.
A half a radian, because the arc length is half of the radius. So the theta here would be a half of a radian. So a radian is telling you how many or how much of a radius length around you are. If I went, do a couple more till you get the concept, because they're not always going to be whole numbers and nice fractions. This is just to show you the whole idea here. If I went 8 inches around, just estimating, so if that arc length there was 8 inches, well 4 inches, still the same circle, I'm trying to keep everything the same, what would this angle measure in here be?
I feel like it'd be 2 radians.
It would be 2 radians. And why is it 2 radians? Because it's 2 radius lengths around. One more, and then tell me you've got it. Okay, yeah, I understand what a radian angle measure is.
Okay.
Still the 4-inch circle.
Last time I gave you
If I go 6 inches this time. Oh, I estimated about to there.
Oh my God, what is that?
6 inches. How big would that angle be? How many radius lengths around is 6 inches if my radius is 4?
1.5.
1.5. So the angle measure here would be 1.5 radians.
How do you estimate,
So we're like doing decimals?
I'm just roughly estimating.
no, but how, like,
Well, I just said this was 4, so I went, that's about 4, and that's about, I probably went a little too far.
what I'm saying, how do you get the 4? Do you put it?
I gave you that, just as a reference. I could have picked any number to start with here. Good? So it all depends on the circle. But, okay, if I had a 2-inch radius, and I went 2 inches on the arc, would the angle be different on this circle than the 2-inch circle? Do you think?
No, I think no.
They would be exactly the same. I could line them up. The inside circle would be in here, you know, the 2-inch circle would be inside, but the angle would be exactly the same. All right, so now, how many, approximately, if this was 4 inches? So we know with degrees, we've got 0 to 360, right? That's the full circle. And then we just keep landing over and over and over again. This time, how many radians do you think it is all the way around?
I was actually asking myself that same.
You were asking yourself, how many radius lengths are there around the outside of a circle?
Are we gonna just find the circumference?
24.
Oh. Matt, what'd you say?
Find the circumference.
The circumference. Okay, so our question here was, how many
Matt just likes the short.
radius lengths go around any circle? Okay, Matt said, well, let's look at the circumference. Once I know the circumference, that's going to give me my answer. What's the formula to get circumference of a circle?
C equals pi.
Pi r squared.
That's area.
Pi times.
Half pi r squared.
No.
It's something with the diameter.
Pi times diameter.
Oh, that's it.
Yep. So,
Beyond.
That's right.
Really? What's the new?
so, If my radius is 4, let's apply it to this circle. What's the circumference of my circle here?
4.
5 times 8.
So it's pi times 8. It's 8 pi. Okay. So what's pi times 8? What is it?
25.132740123.
Okay, bloody, but it keeps going on and on and on. How do I find out how many radius lengths there are around there then?
Divided by 4.
Divide by 4. So if I take that 25, and you divide by 4, that will tell me how many radius lengths there are around there. What does that come out equal to?
6.2831, or 6.2832.
Okay, about a little over 6. We'll just go with that. So there's a little over 6 radius lengths around. So our radian measures are going to go from 0 to numbers just over 6. But we can get an exact value here. We can.
Always divide by 4, or you just...
No, just because this circle was 4.
Okay, sounds good.
Okay, but no matter what, no matter how big my circle is, when I figure out the circumference and I divide by the radius, I'm always going to get this 6.28, always. There is an exact value for this. This is an approximate. I'm going to come back and write down a different formula for circumference. You said pi times diameter. What's another way to express the diameter? 2 radius. So it's 2 pi radius. What's 2 times pi?
5.
What does that decimal is that? 2 times pi?
6.28.
You know, 6.28. Yep. Can't find the pi. 2 pi is 6.28, blah de blah de blah. So there are approximately 6 radius lengths around. How many are there exactly?
2 pi.
2 pi. So there are exactly 2 pi radius lengths around any circle. Nice job on that.
And that's like around any...
Any circle. There's exactly a little over 6 all the way around.
Oh.
Okay. Can I get rid of this?
Yeah.
Okay. Grab your unit circle. Actually, no, don't grab it yet. We'll write them on here. Unit circle, easy radians.
There's hard ones?
Yeah, not intuitive. Okay, there's our unit circle. 0, 90, 180, 180, 270, and our 360. Okay, let's write in the corresponding radian measure for these 5 spots. Okay, 0 degree angle. How many radians is that? 0 radians, because there's no arc length yet. None of the arc length. So it would be 0 radians. There is no symbol for radians. So when you just see a number, that automatically means radians in an angle spot. Okay, 360. What did I say? How many radians it was all the way around?
2 pi.
2 pi. About 6, but exactly 2 pi. So, if it's 2 pi in a full rotation, how many radians at 180?
Hi.
1 pi. Halfway around would be 1 pi.
This is making me hungry.
Oh. So, if it's 1 full pi over to 180, how many pi is it up at 90?
Half pi.
Half pi. Pi over 2 they write it as.
I don't like the way that is.
Makes sense though, doesn't it?
Yeah.
Okay. All right, think about where we're at. We're at 1 pi at 180 and 2 pi over here at 360. What's going to be at 270?
1.5.
1.5, but they don't ever do decimals. What's 1.5 as an improper fraction?
1 pi over 2, like 1 is pi over
No.
2. No?
Good try though.
I tried.
You don't have to write this down. 1.5 equals 1.5. How do you turn that into a improper fraction? 6th grade math.
3 halves.
6th grade.
I don't know when you did this. 6th grade maybe? 2 times 1 plus 1, 3 pi over 2. Just turning 1.5 into an improper fraction is 3 halves, and we just multiply by the pi, because that's what we're talking about. Okay, so we want to be able to convert goofy, not anything nice like these were the easy ones. Maybe I had a 12.5 degree angle, and I want to know how many radians that is. Or maybe I've got a 116.7 degree angle. How many radians is that? So I want a conversion. And I could use any one of these. I could use that 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, or 360 is 2 pi. Which one of those do you think is going to be the easiest one to work with? Not the 0.
Pi. 2 pi.
There's one easier.
Pi.
This is the conversion they like to use, pi and 180. So we're going to use this conversion. 180 degrees is equal to pi radians. So one of the easy things you have to be able to do is convert from degrees to radians. So convert degrees to radians. And we're just going to use proportions to do that. Nope, you don't have to worry about what mode you're in until we start hitting sine, cosine, and tangent. So don't worry about the mode. You can leave it in where it's at.
Are we
So,
hitting that today?
are we what?
Hitting
No, we're not touching that today. We're just going to do a couple simple things. We're almost done. We're just converting one way and then using our circle sheet. So it's all good. Okay, convert degrees to radians. So this is going to be right now. If I had 15 degrees, I want to convert that into radians. So what we're going to do is proportions. I'd set up 15 over radians has to equal, and what's my conversion I can use?
180 over pi.
Yeah, because this was degrees over radians, so I'm going to go 180 over pi. And we want to keep pi in our answer. We're going to go through this the long way once, and then you're going to tell me the shortcut. And this is the long way right now. So if I was going to solve this for r,
Cross multiply.
180 times r equals 15 pi. Don't multiply because we want exact stuff. Now what? How do I solve for r? Divide by 180. So the radians would equal, and now I just have to reduce my 15 and my 180. What goes into both of those? 5. So 5 goes into there 3 times. 5 goes into 180.
It'd be pi over 12.
Oh, 36. Pi over 12?
Yeah.
So pi over 12.
Gonna be.
It went 3 and 36, and then 3 and 36 reduced again 1 and 12. We didn't get the biggest one when we picked a 5. Okay, so that's not horrible to do. That set up the proportions, cross, multiply, and divide. But we essentially did 2 things in here. We ended up taking the 15, multiplying by pi, and then dividing by 180. So I always just, instead of setting up proportions, I just think of it as, boy, I want to get out of degrees. To get out of something, I divide by the corresponding degree. So my first step was to divide by 180. Second step, multiply by pi. Or set up the proportions and do cross products if you like that. I like just memorizing these two steps.
Wait, so you would divide this by
180,
80?
and then multiply by the pi. Stick it in the top.
Oh,
So let's try a couple. 75 degrees. If I follow the two, I could set up proportions, but I don't want to. I'm going to divide by 180, and then multiply by the pi. And the pi usually goes into the top of the numerator. So let me reduce my fraction down first. What does that reduce down to as a fraction?
Five,
5/12.
four.
So 5, now I'm going to stick my pi in there, multiply by pi. 5 pi over 12. Done. That's a little quicker. And then this one, let's go something ugly, 122 degrees, 15 minutes.
We're doing minutes now?
I know. Sometimes they'll tell you to do an approximate value. That means multiply the pi in. So we'll do this one both ways so you know what to do. So it's the same two steps. I'm going to divide by 180. And let's see if we can get, if the calculator will give us an exact answer for this. So we've got 122 degrees, 15 minutes, divide by 180. I think I've got to put the degrees in here. And just to be safe, I'm going to put in the 0 minutes. I wonder if I needed parentheses. Then I'll try to make it give me a fraction. Oh, it did. Ugly fraction.
Wow.
So I divided by 180.
How do you do that fraction?
It's under math. Math. This is the first thing on their frac. And you hit it the enter twice and it converts your answer into a fraction.
Why did I not know this my whole life?
Well, I showed you guys this in geometry. I'm pretty sure.
I could remember you that.
So what did I get? 163 pi over what?
240.
240. Okay, if they want an approximate value, that just means multiply the pi into that and give me a decimal. So I'll take that answer times pi. It's about 2.13 radians. So it's exactly this. It's about 2.13 radians. So it all depends on the directions in the book, whether they want them exact. Exact, you'll see pi. Approximate, you multiply the pi in and round off your decimal. Okay? Can you go backwards? Nope, not yet. Now take out your circle sheet. I'd like you to convert all of those degrees into exact radians in that little missing spot.
What are we doing?
You're taking out your circle sheet. See the missing little dash, the blank dash by all the degree marks?
Oh,
Convert them all to radians and we'll compare your answers here in a minute. So exact, so something with a pi, a fraction with a pi. Divide by 180 times by pi. Divide by 180 times by pi. Divide by 180 times by pi. And you got a calculator that'll kick them back into fractions for you. Reduced fractions. So it's just remembering the two steps.
Only times by pi on the top, right?
Right.
Wait, what did you just say?
I want you to fill in all of the degrees, convert them all to radians, and put them in the little dash that's missing, the blank dash.
Oh.
Oh.
Angle.
Angle.
Divide
Do the divide by 180 on your calculator first, kick it back into a fraction, and then stick a pi on the top. That's the multiply by pi.
Oh, okay.
Yes. So that shouldn't take you too long to run around that. And you've got the 0, 90, 180, 270, and 360 done already.
Okay. What?
Yes?
We're doing-
What'd you do on the first? Tell me which one you did. I'll do it up here.
We're doing
30.
230, but I
Then you just write it on the extra one.
you just do that. right?
Divide by 180.
Yeah.
Reduce that down. What does that reduce down to?
I got 0.16.
Give you a fraction back. Hit math and fraction. 1/6. So when you multiply by pi and the pi goes in the top, 1 times pi is
Oh, I better put the pi in.
pi over 6 is your answer to that one. Okay. Anybody else questions? You guys getting them? Well, we'll compare too. We'll make sure everybody's got the right ones. Writing the exact. We want all exact values on that. 'Cause remember, that's our exact. When it says exact, we go to the circle sheet because everything's exact on there. So divide by pi, or divide by 180, multiplying by pi.
I wish I would have known about those fractions.
Yeah, like this. Like that would've been.
I know I showed you. No, I never showed you in geometry.
No.
It was.
I would remember that.
You would have remembered that trick.
I kept having to go back to my old calculator.
Oh, you went back and forth.
Yeah.
Oh. The fractions must not come up in geometry then.
It comes out as like 1/4, and you just put pi over 4.
Correct.
Okay.
And remember, this is telling us how many radius lengths around.
Wait, are we allowed to write it as like 7 pi over 6?
Perfect. I'd prefer that.
Oh, okay.
We want improper fractions, not mixed numbers.
I'm so used to hitting the math button and hitting angle, I keep hitting this
Oh.
frickin' Z.
I want improper fractions.
So, you get 2/3, like, so it would be 2 pi over 3.
Perfect.
Is that what you write down?
Yeah, that's exactly what you write down.
Okay.
You got it. Austin, did it bite you? Thank you. Was that enough time yet?
Wait, is 0 0?
0 is 0. 0 degrees is 0 radians.
That's your bad?
Well, I don't have, I'm going to borrow someone's. Who wants to be the guinea pig?
I'll need to get it, but
You're not even done.
I'm not done.
I need someone who's done. And Betsy's still pushing away too.
Kenley.
Are you done, Kenley?
With what?
Bring it up, the green sheet.
Oh, I've been done for a couple
Oh,
years
she's
now.
been done for a couple of years.
Oh, look at you.
She wasn't able to get my t-shirts in 24 hours, but she can do this.
My coach.
Okay. All right, let's check. Let me know if Kenley's wrong. Let's point it out if she is. Okay. 0. Next one, pi over 6. Pi over 4. pi over 3, pi over 2 is at the 90. 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Are we so far so good?
Yes.
Okay, next, 7 pi over 6, 5 pi over 4, 4 pi over 3, and 3 pi over 2. How'd you do there?
Yes, you did.
Nobody disagrees?
225, 5 pi over 4.
5 pi over 4. I'm just checking. You should, if you got something different, we can double check to see who's right.
I got 5 pi over 6, but I'm probably wrong.
Let's check. So 225, I'll double check it. 225 divided by 180. 225 divided by 180. Math, frac, 5/4.
Math, frack.
Okay.
That's so funny.
Next one. Let's see. After the 270, we're at 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Kenley did a good job.
Wait, what? 11 pi over 6. That's
Yep.
not making
We're going to check this one. 330. 330 divide by 180. Math, frac. 11 pi over 6 is correct. No mistakes for Kenley. Nice job. There you go.
Yeah,
Okay.
I assume so.
2 little things left to do. You just went degrees to radians. Can you go backwards?
No.
So the first thing, to get out of degrees, we divided by 180, and then we multiplied by pi, get into radians. Out of this, into that.
Multiply, then divide.
Okay?
You know, I thought we were done for the day.
Almost. Have we done anything challenging today?
Yeah.
No, that's why I was hoping it would be an easy day.
It is an easy day. Radians to degrees. Okay. First step. You can set up proportions, or I always think what I want to get out of. I want to get out of radians. To get out of something, I divide. What would I divide by if I want to get out of radians? Divide by pi. I want to get into degrees. What would I multiply by if I want to get into? I multiply.
180.
Multiply by 180. Get out of, get into. Divide to get out of, multiply to get into. If you can think that way, it kind of comes right back. So, converting, let's say I give you 7 pi over 20 radians. I want to get into degrees. So, my first step we said was divide by pi. How do I divide this by pi? Cross it off. Divide by pi, it's going to cancel it. That was easy. So I'm left with 7 over 20. Now what do I have to do?
Wait, why'd you just chuck the pie?
Because I'm dividing by pi. If I actually divide by pi, dividing by pi is multiplying by 1 over pi.
Okay. Oh, okay, cool.
And they cancel. It's easy to divide by pi when the pi is there. Cross it off.
New times by 180.
Now I got times by 180.
And you get 63 degrees.
Calculator will do that for you. And what did you say it was, Matt?
63.
63 degrees. Is it always going to come out a nice whole number? No. How about pi over 10 radians?
We'll
Bye.
cross the pie.
What's left if I cross off the pi?
10.
1/10.
Oh, I guess.
1/10. A lot of people want to just bring the 10 up and make it 10. Oh no, it's 1/10 times by 180 gives us 18 degrees. 1 radian. So I'm 1 radius length around. Same 2 steps though.
We'll divide by pi.
Okay. I don't have a pi to cross off, so I actually physically have to divide by pi and then multiply by 180. And we don't leave pi in this answer, so you pick up a calculator and you do this and you round it off. So, 57 degrees, so almost to 60 degrees what your 1 radius length around is. So if you don't have a pi to cancel off, you actually have to type it in the calculator. And we'll do one more. 2.6. 2.6 radians is about how many degrees? 2.6 radians is about how many degrees?
$140.
140, you said?
149.
149 point.
No, it would be 148 point. Oh, yeah.
Let's go 2 decimals.
140.
Yeah, never mind.
Oh, 2 decimals?
2 decimals.
148.97.
Okay, degrees. Okay, last one.
Where is that? Okay, I'm not starting a whole entire new page for one.
And there's like,
Start a whole other page.
there's 3 and they could fit on one line if you wanted to. You could just make them horizontal. There's no work involved,
Oh,
I'm
really?
just putting-
really.
Just putting it in a random spot on that page.
I would like the tangent of a 2 pi over 3 angle.
You said we weren't doing this today.
We're not touching our calculator. I want an exact value. No decimals allowed. I want an exact value. Where are your exact answers at? On your circle sheet. So you're reading off of the circle sheet. Exact. I'm going to put the exact here.
2 pi over 3.
Yes. Mm-hmm. We did the 2 places. I just said go with 2 places. The directions in the book will tell you how far out. I think it's 2 places.
I second that.
I got a seconded on. So what are we doing here? What is this asking for? Is this asking for an angle measure or a ratio? It's asking for the tangent ratio of this angle. So find 2 pi over 3 radians on your sheet, and then give me the tangent ratio at that spot. And what did you say it was, Axel?
-3.
And Matt okayed it.
Well, not okay, but
Yeah, must be right. How about the cosine of negative pi over 4? What does a negative angle measure mean again?
You have to go the opposite.
Go in the opposite direction. So find pi over 4. Where's positive pi over 4? And then go that much in the opposite direction. And give me cosine.
Square root of 2 over 2.
Michaela, you were all the way there. You followed me all the way through my directions until the answer. Did you get it? No. Oh. I saw you go up to pi over 4. Right? Then you went down to negative pi over 4. Okay. So what's the answer?
Square root of 2 over 2.
Square root of 2 over 2 is correct. Any problems finding that from anybody? Otherwise I can get a sheet up here and show you.
Yeah.
You need a sheet? Can I have your sheet?
Now you're going to throw cosecant in there, aren't you?
Oh, that's not any harder. Pi over 4 is up here, and I can look, oh, that's 45 degrees. It doesn't matter, same spot. So I'm going to go backwards 45 degrees. Oh, that's here. So now I want cosine. Oh, that's the x value. Done. What if I give you some, this is the last one, it's the trickiest one. Cosecant, that's not the tricky part.
Thanks, Matt Casey.
13 pi over 6.
So you're going to do it anyways, guys.
13 pi over 6. Anybody find 13 pi over 6? Oh, you can't find it. Why is that not on there?
Cosecant.
It's not a cosecant.
Wait, it's flipped, and that's technically 6. Oh.
It doesn't matter. I could have any trig function under there. You've got to be able to find this angle measure. Could you find it?
No,
Why not?
because the limit does not exist.
Oh, it's not a limit. Wait, let's see. How many degrees is that? Let me see. Divide by pi. What's 13/6 times 180? Oh, it's 390 degrees. That's why it's not on there. It's over one full rotation. It's in its Halloween costume. So, anytime you can't find this, turn it into degrees and you will know why. Did I know that was over one full rotation?
No.
Not really. So the first thing I did when I ran into something like this was, boy, that's the same thing as the cosecant of 390 degrees. I don't care that I'm out of radians. I want to know what this value is. So what are we going to look up? The cosecant of what? Where does 390 land?
30.
30. That one kind of grew a lot horizontally. How do I get a cosecant?
Flip side over.
Flip sign over. What's sign flipped over going to turn into? 2. Sorry, Betsy.
Take up one line.
I forgot that one grew. Okay, your assignment then. And this is a lot of converting and then reading your sheet. Oh, let's see. What is, oh, it's the wrong one. Right here. It's Thursday today in Trig. 3-1.
Wow, don't mean.
Page 113.
So, Betsy,
I'm going to switch this back.
square it over, I know what's.
Oh no, 21 to 55 odd. 58, 66.
It's just one of those days.
And 80. There you go. It's not a lot.